Okay.
Yeah. Are there too many people driving? Ta-da!
Ta-da.
Take it away, Graham.
Thank you very much. Everybody hear me? Good stuff. Okay, so the title on the agenda ended up being a bit long to actually type out, so that's what we've ended up with there. And yes, this is a talk about layer 2 networks, kind of quite general, but obviously, I mean, I'm from Vumatel. We're a local open access provider, providing layer 2 connectivity, amongst other things, for a number of ISPs, so many of you are probably using our services. And so I just wanted to chat a bit about what we're seeing, some of the general stuff, and then hopefully have a chance at the end to chat through any questions you might have. So that's me. There's some contact details there if you need them. And then, yeah, what we're going to talk through some of the kind of the fundamentals, some use cases and challenges, and then hopefully some solutions. Okay, so looking at layer 2 versus layer 3, and I realize that this is kind of sort of 10, 15, 20 years ago. A lot of what we do currently is not exactly this, but the essential idea was that layer 2 was a flooded broadcast, every endpoint on the network type of protocol, and forwarding to a specific individual interface is something that came much later at layer 2. It is now fairly standard in most switching equipment. That's why we call them switches and not hubs anymore. But fundamentally, it's a recent thing, and a lot of the basic functionality of layer 2 still assumes that a broadcast or flooded to all interfaces will continue to work. By contrast, layer 3, as we all know, unicast goes one direction, goes to one endpoint. If you want to get it to go to multiple endpoints, you have to work very hard and you have to fight with routers and battle them with multicast. And I don't know anybody who's not got war stories from trying to do that. And the big difference from a networking point of view is what happens when things go in the wrong direction. So at layer 2, there is no hop counter. Now the hop counter is something that's attached to each packet, and at layer 2 there is no hop counter. So a network packet will arrive on a device, and that device will look for a place to send it forever. It will never stop looking for places to send it. In the loop scenario, so when a packet comes round and ends up back on the same device, that same device will see it again, have no idea that it's seeing the same packet, has no way of knowing it's the same packet, and it will look again for some way to send it, and it will send it again. And that creates packets that circulate continuously. And then when you have a scenario where, for any reason, that packet is a broadcast packets are intended to then go out all of the interfaces on your networking device. And that creates an amplification effect. So one packet comes in, it gets sent out 4 times, it goes around the loop, it's now four packets, it arrives back. Oh, we've got 4 packets, multiplied by 4, suddenly we've got 16 packets. And this breaks networks very, very quickly. By contrast, on layer 3, every single packet has a time to live or a TTL marker on it, and once that packet has passed through a certain number of devices, and I actually don't remember what the limit is, but it's sort of 50 or 100 or something, so it's a very big number, but I think it's 50 or 100. Does anybody know? 255, is that? It's also different per operating systems, I think, or it used to be, but yeah, 255. But the point is that although that's a relatively big number, you have to have gone a long way around the internet to have gone through 255 routers, but there is an endpoint. When you get to the 255th device, the TTL is at 0, and that device throws the packet away. And so you suppress that. If there's ever a misconfiguration, if there's ever an issue in the network, the traffic just disappears. So it's inconvenient. I mean, your packet's not going to where you want it to go, so you don't have connectivity, but your network doesn't implode. So where are we seeing layer 2 in use? In the data center and enterprise. I've seen a lot of this. I previously worked for an enterprise ISP/MSP. We worked with a lot of enterprise users. We worked with a lot of data center environments. And a lot of people in those environments like layer 2 because it's in their own space. So if they're running a server in a rack and they can connect between all of the servers in the rack without having to worry about the router or the firewall that sits in the other side of the building belonging to the other department, then they're happy. And then they get used to working within their one rack and they say, oh, well, I need to be on the other side of the data center as well, and we'll just get that layer 2 to the other side of the data center. And then the next day they go, oh, well, I need another data center on the other side of the town for DR. Well, let's just extend that onwards towards there. And you end up with these layer 2 domains that just grow and grow and grow because it's something that people are familiar with. It's not going outside of what their knowledge area is. But also we see that people are recommending, software designers recommend that you do your redundancy with this particular type of protocol that only works on layer 2. You've got a cluster of servers and they have to be connected together at layer 2, otherwise they're just not going to fail over or whatever they're needing to do. And then even on the LAN side, we see the same thing. Users who build enterprise LANs, who get comfortable with big layer 2 networks, and when they need more endpoints on the layer 2 network, they just make the layer 2 network bigger. And if they need a new branch, they just plug it into the edge of the layer 2 network. And they don't have to worry about these horrible things called routers. And they don't need to worry about buying these horribly expensive things called firewalls. And they don't need to learn about these horrible things called routing protocols. And it's simple. Unfortunately, it doesn't scale. And then there's the big one at the bottom. And this is a misnomer, I think, perpetuated sometimes by us as the operators as well, that when you do a trace route, every hop line you see in the trace route is somehow killing your performance. So if there's less in the trace route, you've got a better service. And so people then hide away bits of their network by doing it all in layer 2 just so that their trace route looks shorter. Now, the reality in modern networks, well, not even in modern networks, the reality in networks is that if you need to get from A to B, you need to go through a certain number of devices to get there. Whether your diagnostics tools tell you that you're going through those devices is largely irrelevant. You're going through those devices. And so not seeing them in the trace route doesn't give you better performance fundamentally, but there is this false belief that somehow you're getting better performance by having more layer 2 and less routers. Now, in my view, 90% of these problems can be solved with DNS at layer 3. You don't see Google coming to you and saying, no, you must bring a VLAN into our data center in order to get google.com. You don't see Facebook coming and saying, no, but you have to do VRP and you have to do it on this. The way that the big guys do it is they send you a DNS address and they shuffle you around and they send you to a different server to get the content that you need. And we have a lot of people, and this is particularly in the enterprise space, but I see this also in the ISP space. And we are doing people a disservice by not guiding them in the direction to say, well, couldn't you do that with DNS? Couldn't you have your failover to your backup site where you actually have a different IP address on the server in the other location? Because that's better for network design. That you then, when you want your website to suddenly come up on your backup server, just update the DNS record and you point at the new website. Now, kind of more into the area that I'm working in at the moment is access networks. So circuit-based services, dial-up modems as they were back in the day, and even ADSL to an extent, were circuit switch. So you had a point-to-point from your device through to an endpoint. As things have evolved, most of the modern technologies, the PON technologies, the fiber-to-the-home technologies, are no longer using any of these specifically circuit-based technologies. They're using Ethernet type switching and layer 2 switching. The mobile network architecture still effectively from your phone into the core network still creates a circuit. And so the mobile networks are still kind of in a funny space there where they still have the more circuit-based architecture, but even they're moving in different directions. And so in order to have open access fiber to the home at scale, you're needing these big layer 2 networks. And these big layer 2 networks fundamentally require broadcast messages to go over them. Going back to what we said at the beginning, originally layer 2 was a broadcast protocol. And so these protocols that are running over the layer 2 networks require broadcast to be able to function. If you can't send a broadcast message over your FTTH provider, the triple PoE discovery, which is the first step in connecting, never gets through, and your ISP can never give you a connection. If you're using DHCP, that first step requires the broadcast, doesn't get through, you never get connected. So we have to allow broadcasts, even though there is a significant risk in allowing those broadcasts, and that creates a risk in the stability of the network. So as we have mass market adoption, I mean in South Africa we've got fiber to the home in most of the city areas now. There's massive work going on at the moment to get fiber into the more rural areas, underserviced areas, and things like that. And that requires internet access at scale. And because of the back-end technology, that means that we've got layer 2 networks at scale. So challenges that I see with the networks we build at Vumatel, and also with the expectations from ISPs in the industry, is that people want to do centralization. People don't want to have to deploy a POP in 15 locations around the country. People want to put an IP POP in Johannesburg. They want to service the whole country from Johannesburg. When you get bigger, some of the bigger networks will then start to move out, and then they'll go Joburg, Cape Town, Durban. Then they've got 3 POPs. But there's basically no ISP running on an open access network, and this goes back to the conversation we were having about Netflix. There's no ISP in this country that has got more than 3 POPs delivering onto the FTTH networks right now. So everything is centralized in either Joburg, Durban, or Cape Town. Then we have open access, so we have ISPs wanting to deliver services over the open access fiber networks. And what that means is that we've then got ISPs with their own particular set of requirements, their own particular architectures, the number of devices they want to do, the kinds of CPEs they want to use, all these different dynamics that you then don't have control over, and they're doing it over third-party networks. And open access in South Africa ends up being the perfect storm of the two of those together. And as I said earlier, Layer 2 is a fragile protocol. It's being used beyond what it was originally intended for. And there's a continuous trade-off between scalability and stability and the cost of those two throughout the entire value chain. ISPs don't want to build POPs. The fiber network operators don't want to have infrastructure in places where it's underutilized. It's a continuous challenge. So we are some pain points here. MikroTiks are used by a lot of people in this country, a lot of ISPs in this country. I like them, they're very useful, but they also take certain things with a bit of enthusiasm that's not typical of some of the other vendors. And they're less conservative. Let's say they're less conservative than the other vendors. And that means that they're very innovative with some of their capabilities, but less conservatism is, again, a trade-off with stability. So neighbor discovery protocols are standard across most vendors, but MikroTik takes it a step further. In order to be universally compatible and work with every single other device, every single neighbor discovery packet that a MikroTik sends is not just one packet. They send 3 packets. One for the Cisco protocol, so the Ciscos can see the MikroTiks. One for LLDP, which is kind of the more general standardized protocol. And a third one that's their own proprietary protocol. And they send all 3 of them every time. So suddenly you have a device that's sending 3 times as much noise into the network as a more traditional conservative vendor. They also, by default, don't only send those discovery protocols on their physical ports. Most other vendors will only send the discovery port on the discovery protocol on the physical port, whereas by default, MikroTik sends it on every single VLAN, every single sub-interface, every single bridge, every single component. And so a single router can be sending out tens or even hundreds of these messages every cycle, which I think is about 1 minute or something. They also have these other useful things. MacTelnet, I'm sure any of you who've used a MikroTik will know about MacTelnet. It's a great management tool when you've completely messed up all of the layer 3 config on your device. And it's a backdoor, and you can get in and you can fix stuff and you can get yourself out of trouble. But you should only be using it to get yourself out of trouble. If you are using it as your default management tool, then you should be rethinking that. We've had ISPs come to us and demand that they allow us to do MacTelnet across our network because that's the only way that they can manage their customer routers. And I'm going, your customer device should have an IP. If the customer device stops having an IP, then that's a problem. And there's plenty of protocols that exist that have been developed by the people who've built big networks to do auto-provisioning and to do remote management and do all of those things in a scalable, sustainable way. The important point here as well is that MacTelnet, people assume that because they're typing a MAC address into the message that they're sending a message directly to that MAC address. But the way it's implemented on the MikroTik is that the MikroTik just sends a broadcast message. So every bit of communication that you send to your device is being broadcast to every other device in that VLAN. And as far as I'm aware, that's all still unencrypted. So any customer who happens to do a bit of traffic sniffing on their port can see the username and password that you use to log into their neighbor's router, which is probably the same one that you configured on their router as well. Security problems all around. So use the tools in the right place, but understand the limitations, and yeah, use with care. Another one I've seen is spanning tree protocol. Spanning tree is very old. The people who designed spanning tree have said it's very old and it's not really suitable for today's requirements. It's a very blunt tool for managing networks. I've only seen it work really well in extremely simple networks that either have one single ring or maybe a ring with a little sub-ring on it. Anything more complicated than that, the moment you get into a network that is meshing or is getting more complicated than what a simple single ring, you're going to start having challenges with the spanning tree, and a lot of people then just get frustrated because spanning tree is not the kind of thing where you just plug in another device, plug in another device. You have to design it at the beginning and you have to make sure it works like that, and you have to redesign the network if you want to change it. And that's not how networks are built these days. We're plugging in new network components all the time. So the first rule there is, if you really want to use spanning tree inside your network, and I would say that it's a good idea to consider whether you should just turn it off completely because it might not actually be helping you. But if you really want to use spanning tree inside your network, never send it outside of your domain of control. So your data center, your rack in the data center, whatever, if you want to use spanning tree there, that's fine, but don't send it to your transit provider. Don't send it to your backhaul provider. Don't send it to your access provider, because you're not saving yourself from anything, because your provider is not going to interpret those spanning tree messages and make decisions on them in any way that you might think they will. So it's not benefiting you, and you're just flooding more garbage into the network that is not helping anybody. Similarly, you should not accept spanning tree messages from anybody, and you should not act on spanning tree messages from anybody, because if your network and their network have not been designed together as part of that spanning tree architecture, there's no way for them to interpret the messages that they see. I've seen a lot of people who insist on using BPDU guard and then screaming and shouting when their interconnects at the data center shut down. But you can't control what's coming from third parties, so don't use BPDU guard. BPDU guard is a LAN, office LAN, enterprise LAN feature. It doesn't have use in the data center. And if you need redundancy, look elsewhere. The layer 3 underlay with layer 2 overlay products, or protocols rather, are mature, and at this point like 10, 15 years mature. They're available, they're high performing, they're available built into chips from just about every vendor. There's really no reason to not be using something like MPLS, VXLAN, or there's a few others as well, but those are the two most people know about. There's no reason to be not using one of those rather than trying to connect everything together at layer 2. Storm control and port security, related again. And again, to the point, don't trust anybody. Assume that your neighbors, the people you connect to, the people you interconnect with, your customers, your providers, even other organizational units within your business. If you're the ISP department and your IT department is now a separate team, just don't trust them. Not because they're implicitly bad people, but everybody makes mistakes. Put the safety nets in place that you're not going to get taken down by a mistake that somebody else makes. Storm control, limiting the amount of broadcast messages so that when that condition occurs, that you have the traffic looping, that it's amplifying, that you create some kind of limit that stops that from getting out of hand. But take care when you're doing that, because like we said earlier, PPE, DHCP, those protocols all need broadcast messages. So you can't just block all of your broadcast messages, you have to set a threshold, and it's actually important to go and figure out how much of this is on your network, give yourself a safety margin for your growth in your network, whatever, and set the limit, so that the broadcast messages can never consume all of your traffic, but there still is enough for what's going on in your network. The other important thing, just to specifically on broadcast storms like this, in South Africa, remember that when we come out of a load shedding stage, you have thousands and thousands of subscribers coming back online at the same time. So whatever you're doing in terms of storm control, make sure you're planning that out, that allows for that peak, that as the users come back online, as they're trying to reconnect, you have enough headroom in your thresholds that they can all get online quickly, because customers have been sick of having no power and they want to be back online the moment the power comes back on. And in port security more generally, set reasonable limits for what you're allowing into your network. A customer plugging in a single router has no reason to send you 100 MAC addresses. So set a limit that's reasonable, because by default, the equipment will accept whatever you send. And then something specifically that we're also seeing on the fiber networks is these junk people send, intentionally, unintentionally. Only allow the stuff that's needed for the service you're delivering. So if you're delivering triple PoE services, only allow triple PoE ether types to come through, etc., etc. We've had scenarios where people have bought some kind of weird HDMI repeater thing that happens to have an Ethernet cable on the back, and, oh, this is cool, it's got an Ethernet cable, maybe it'll plug into a switch. And it does actually plug into a switch because it's talking Ethernet. Only problem is that the little HDMI repeater box is so dumb that it's just got a hard-coded multicast MAC address on each side, and they're just chucking multicast frames, and a network device doesn't know what to do with it and goes, well, I don't know what multicast is, so I'm just going to broadcast the stuff. And broadcast sends you, the user's watching 4K HD content, and the next thing, some little consumer device is flooding the network with junk that is irrelevant to the service you're trying to deliver. The last big one is, I know everybody's bought a bunch of these secondhand. Everybody has. I've got them as well. But please throw them away. There are known bugs with them. You can turn on storm control. You can turn on rate limiting. You can turn on VLAN allowed lists. And the packets still get through. There's a bug with IPv6 multicast packets that they just pass through the switch and they don't stop. And we've had incidents where somewhere someone started an IPv6 multicast packet, got into an ISP's network, stormed inside the ISP's network, got into our network, stormed in our network, got back to another ISP's network, stormed in their network. That ISP then carried that traffic from Joburg to Cape Town on their backbone, because their backbone was just a bunch of switches all connected together on layer 2, stormed back into our network in Cape Town, and took out half the country's internet. So the one use case that I still see for these is if you've got servers or routers that you control that are in your environment, sure, carry on using them. But if you've got one of these connected to a fiber operator, connected to a backbone link, or connected to any third party like a customer, please just throw them away. So in conclusion, don't underestimate layer 2. It's easy to get started, but when it gets big and it breaks spectacularly. And keep it clean. Again, plugging it in the first time, everything works, it looks wonderful. But when you've plugged in 10,000 first times, you suddenly have a lot of mess. And you end up with a lot of noise, because a lot of devices have these broadcasts, these neighbor discoveries, all of these little things that they do that are convenient and useful, but at the scale of tens and hundreds of thousands of these devices, it creates a lot of noise. And always look for ways to solve the problem that you're trying to solve with layer 2 at layer 3. I know there's been a lot of discussions over the years between the ISPs and Vumatel on the open access and how the open access layer 2 model is, the ISPs like it a lot because it's convenient. They can put down a triple PoE BNG server and it works very smoothly, but it doesn't scale. And we're at the point now where difficult decisions have to be made to say, well, if we can't keep the layer 2 network safe and stable, we have to move to layer 3. And everybody hates OpenServe's layer 3 model. But there's a reason that it exists, because it scales and it's stable. So, yeah, work with us. We're keen to carry on delivering stuff, but we're also keen to make sure that it's stable. It doesn't break. Okay, I'm done. Any questions? Are we doing questions?
Got a couple moments for a few questions. Anybody with comments?
Hi, so with regard to last part of security between customers, especially with retailers deployments, I've seen, I want to say for business specifically, but I've seen GPON providers who have customers all visible at that level at the edge to there. How have you fixed for that? Or what have you seen in the worst?
So most of the vendors have got some kind of button or knob that will do some kind of isolation. And in different places it works. So in a simplistic term, if you're talking about a single OLT or a single access switch, you do the, Cisco calls it what, for private VLAN or something, and the other vendors have got client isolation. There's different names for it. And within the domain of a single device, generally it works. Where I see it failing is when it then has to go back into a bigger, as you say, VPLS network. There are ways of doing it with VPLS that in theory should work, but it becomes a very specific sort of design thing about being very specific about where you build each tunnel and where you terminate each tunnel, and considerations around redundancy. It does get quite complicated. So right at the customer edge within the context of a single neighborhood serviced by a single LLT, certainly that's something that you shouldn't accept as happening. It should be blocked. But we do see a scenario where, as it gets further into the network, depending on and also depending on how the network's been done. VPLS, it's a manageable problem. If you're talking about a backhaul network built on ERPS or spanning tree, there are pretty much no ways of actually dealing with it because the traffic's going back via the backup route when there's a link failure, and then you start seeing people on the other side.
Jared Launch, Modified Technologies. I'm curious in part about how the open access networks are actually working here in South Africa. What we saw in the US is we saw in the late 90s, there were these two big providers, Cobad and North Point, which are both now, John is over there laughing, but they're both now defunct because the open access model, and line sharing agreements and stuff like that really didn't work at scale. And I'm kind of curious how that's, how that actually is working at scale here, or maybe in part it maybe has some challenges here. As you mentioned, everyone's backhauling to the same, couple, locations. But at least then we would get a handoff, like it would basically be, an ATM interface, but now you can do that probably with VLAN, or trunked, VLAN with, or a trunk port with a whole bunch of stacked tags, and stack them inside there, so you get more than 4096 on a port. Is the access model that they hook up to an OLT, like the end user hooks up to an OLT, you assign them to a VLAN, that's the VLAN for that single provider, and then they just backhaul it nationally?
Yeah, correct. So I mean, certainly from our point of view, we try and segment it into the three major regions where the three major data center clusters are. So we try and avoid national, but like I said, there are ISPs who like to be just in one city and just open access to the whole country. Broadly, there's two models that are at play. So the one model is configure the VLAN at the OLT, and that VLAN ID matches a VLAN ID that's allowed on a switch to the ISP, and that VLAN just gets all the way through. Mark will tell you how much the ISPs love that because it gives you a lot of control to pretty much deliver whatever kinds of services. You've got a lot of control over kind of what you're doing with the service delivery. The other model that we've got is with various different variations, but where the open access operator operates a BNG, and in some cases with L2TP, I think, you probably know that protocol better, L2TP, and then you're terminating on an ISP LNS, so that's IP from the BNG. It's a good model. It ends up being very expensive hardware-wise. So that's the model that the incumbents telco currently uses, but all of the competitor FNOs like myself and all the others didn't go for that because it's got massive capital costs up front. But it actually scales much better. And then the third model that we use is kind of similar, terminating on a fiber operator-owned Layer-2 device. We've got both BNGs and DHCP gateways, and then dumping out into a VRF. And then each ISP gets their VRF handed off to them at the interconnection point. Again, that scales, but then the ISP doesn't control what IPs are allocated. The ISPs don't like it because they have their hands tied. There's challenges with the amount of IP space, obviously, with IPv4 running out. The ISPs are trying to squeeze like every single customer, and you've got it becomes a management challenge it comes with other challenges, but the scaling, it works very well.
Okay, and then I guess, I guess my last question would be, have you thought of just delivering a managed routing service for them? It sounds like that last thing that you mentioned might sort of be it, or something where you use a Tomahawk 2 chipset device, which are relatively inexpensive, and be able to do that in order to not have the huge national broadcast domain issue, and something like that. It seems like some sort of intermediate service that in there
So us as Vumatel, the service we deliver to the lowest income areas is pretty much that. We own the ONT. There's no ISP router. We configure it all remotely, managed through the OLT management systems that exist, the technologies that exist there already. And in that scenario, we control and manage all the way from essentially the Wi-Fi in the user's house, all the way to the interconnection point, and then again, we just hand off that VRF with that pool of IPs that belongs to that ISP. They do the internet breakout beyond that, but everything inside of that is then managed, and it does scale better.
All right, last question, real quick, Ed.
Yeah, just a quick one on your thing about people not necessarily breaking out in a smaller region, everyone funnels into bigger areas. I think the biggest issue there is that many FNOs make it expensive for that to happen. We know one big FNO recently pushed up port pricing and forced people up to 10 gigs. And what they've effectively done there is funneling people's traffic to Joe. Because people are now suddenly consolidating because it just doesn't make sense for them. People who do a great open serve, if there's some infrastructure facility, it's super cheap to run almost from anywhere. Same thing with EFA and Africa and those ones. But that's mostly these business services. But I think if there's a want for it to happen from the F&O side, if you make the conversions make sense for like, oh, you already are on the 3 areas, you pay whatever prices, we need a full area, make it free. That's how I would see it make sense. Instead of trying to price them into splitting it up into, or not split it up. So, yeah, sorry, it's in this case.
No, I agree. I mean, there's a lot of good reasons to incentivize. I mean, certainly from my point of view, I don't want people picking up the traffic in Joburg because from an operational point of view, that's more trouble tickets that get logged with me to say, why is my latency never below 20 milliseconds? I was like, well, because that's how your ISP chose to design their network. And I don't think that's the service we should be delivering. But yeah, we have to have complicated discussions with bean counters to make some of those things work.
With the P exchange happening, it's our goal to try and make that more easy for people and make more sense, but it means that most of it will do so. We can push for more study would be great.
Okay.
All right, great. Thank you, Graham.
Thank you very much.
All right, next up we have 3 lightning talks. There'll be about 10 or 15 minutes each. Our first one is going to be Yolandi, and it'll be, I just told something together, why we are so far behind or something like that. Anyway, she'll be the one that'll be able to excellently answer what the talk is, and I'll get her slides up here real quick.
Just please.
Let's see. How far behind are we?
And this one?